Let us look at proposition number 19 of book 6 of Euclid's Elements. The proposition says similar triangles are to one another in the duplicate ratio of the corresponding sides. Okay, so we are given these two triangles ABC and DEF, right? Such that AB is to BC equal to DE is to EF, and angle B is equal to angle E. Okay, now let's understand what this duplicate ratio means. Let's say we have a ratio 2:3. Duplicate ratio would mean 4:9. That is 2 square is to 3 square. Triplicate ratio would be 8:27, which is nothing but 2 cube is to 3 cube. So that is what basically a duplicate ratio or triplicate ratio means. We have AB is to BC equal to D is to EF. If we take the alternate ratio of the alternates, we can say AB is to DE is equal to BC is to EF. What we need to do is find a point on BC, say G, such that we can form a proportion BC is to EF as EF is to BG. So BC, EF we need to figure out BG, which is the third proportion. We know how to find the third proportion. Very briefly, this is what finding the third proportion means. This is equal to BC. This is equal to EF. I extend BC by the same magnitude as EF, and I draw a line parallel to this line. So here, this would be my third proportional. BC is to EF as EF is to BG. Let's mark that point G and let's join AG. Can I say BC is to EF as EF is to BG? Yes, because on that basis itself, we found this point G. In triangle ABG and DEF, we have AB is to DE as EF is to BG. From where did I get this? Remember, AB is to DE is equal to BC is to EF. But BC is to EF equal to EF is to B. So I combine these two statements and write it as AB is to DE equal to EF is to B. What does this mean? AB is to DE as EF is to BG. This is a reciprocal proportion of the sides about the equal angle. That means these two triangles are going to be equal based on a proposition which we have seen. So now I can say triangle ABG is equal to triangle DEF. Based on a definition, I can say BC. Look at this. BC is to EF equal to EF is to BG. I can, if three magnitudes are in proportion, right, I can say the ratio of the first with the third has the same ratio as the square of the first and square of the second. This is based on a definition. I can say triangle ABC is to triangle ABG is equal to BC is to BG. On what basis? Remember, ABC and ABG are under the same height. So that means they will be proportional to the bases. So here base of ABC is BC and base of ABG is BG. So triangle ABC is to triangle ABG is equal to BC is to BG. But BC is to BG equal to BC square is to EF square. So which means I can write this proportion like this, and triangle ABG is equal to DEF. So that means triangle ABC is to triangle DEF is equal to BC square is to EF square. Triangle ABC is to triangle DEF is equal to BC square is to EF square. That means we have shown similar triangles are to one another in the duplicate ratio of the corresponding sides BC, and that was proposition 19 of book 6 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.